Now we want to look at the normal distribution, and we're going to use this example. So it says here the average return for a large cap domestic stock over 3 years was 14.4%. And we have the standard deviation over that same time of 4.4%. So in order to use the normal distribution, we always need these two things. We need the mean, and we also need the standard deviation. And so we have them. In terms of part A, it asks us what is the probability that the return is at least 20%. So here are the steps we want to take when we do these kinds of problems. So here are the steps. So for step 1, make sure you write down the probability statement. In this case, it's probability that x is bigger than or equal to 20%. So at least means bigger than or equal to. Number 2, convert x to z. So you're going to take whatever this value is and convert it to z. And this is the formula that we use. X minus mu divided by the standard deviation. So this mu represents the average value or the mean. And so that's what we have here. And both these numbers are given in the problem. So let's take our 20, subtract the mean, the average value, divide by the standard deviation to get 1.27. And we use 2 decimal places because when we use the t-tables, that's what we have, 2 decimal places. So we have to be consistent with that, okay? So round to 2 decimal places, do this on your calculator, and then round to 2 decimal places. Step 3, we want to rewrite the probability statement in part 1 where we have z instead of x. And so it's still going to be greater than or equal to, because we're not changing this just yet. We're just turning the x's into z's. So that's what we do here. And we also do that for the number, because we just found the number 1.27. Let's go to step 4. In step 4, you want to sketch the bell curve. And so this is what the bell curve looks like. It's symmetric about the 0. So it's symmetric about 0. And then our 1.27 is above 0. So we want greater than that amount. Okay, so we're going to shade the area that we want. And remember, when we looked at uniform distribution, we learned that for a continuous random variable, the area under the curve is the same thing as the probability. So that's true for the normal distribution as well. Okay, so we're saying greater than because that's what the initial problem had. It had greater than or equal to. And so that's why we shade to the right. Step 5 is very important to understand when we look at normal distribution, okay? So when you use the normal tables, you have what we call cumulative distributions. So cumulative means it includes everything up to that point. So for example, if I tell you that the final exam in the class will be cumulative, that means it includes everything up to the point of the final. So in that case, what we're saying here is we want to convert it to that form to be up to and included. So if we say what is the probability that z is greater than or equal to, that's not up to or included, that's above this point. So what we're looking for is less than or less than equal to. So for example, this one, okay? So we take greater than and we're going to subtract from 1 to get the area that we're really, to get it in cumulative form. So we need to see a less than. That's pretty much what's going on here. We need to see a less than for us to use a normal table. So that's what we're going to do, okay? Why do we subtract from 1? Well, the reason is because the total area under any curve is going to be equal to 1. And so if we want this area that's greater than, and what we have is the less than area, then we just subtract what we have from 1 to get the shaded area. So that's what's going on here. All right, so once we have this less than, then we can go to the normal tables, and that's what we will do next. So in terms of the normal tables, this is how it's going to look. And depending on where you get your normal tables from, it's going to look slightly different. But the gist of what's going on is pretty much the same, okay? So you're gonna get your Z value in this way. In the rows, you're gonna get the first 2 digits, and then on the column, you get that third digit. So remember, we wanted 1.27, so we get the 1.2 here, then we look in the column for the 7, and our value is 0.8980. And so let me show you what the normal table looks like that I have. So this is the one I use, and for me, I would go down to, this is Z, so I'm gonna go down to, in fact, let me just show you guys this if I can. Notice the graph at the top. Almost all normal distributions have this graph. This shaded area tells you that it's cumulative. Notice it's less than the Z, and it says it here as well in the title. It says it in the title as well that it's cumulative. Okay, so what we're looking for is Z. We're looking for 1.2. That's the 1.2 right there. Then we go across to the 7, across to here. So 1.2 and 7 gives me this value right here. So that's what I just wrote down. And so we're going to plug that in to our equation from earlier right here. When we do our subtraction, we get 0.102, and that's our answer. Okay, in part B, we need to find the probability that the return is less than 10%. So let's go ahead and do that one. Again, we start by writing our probability statement out. What's the probability that X is less than 10%? We convert our X to Z. We get -1. We are going to rewrite our statement, which is that Z is less than -1. Then we sketch our graph. Again, the graph doesn't have to be perfect, as long as you can decipher what's going on. So let's see what we got right here. There we go. So notice it's -1, and we're going to go shade it less. Let's keep going. Then we're going to go directly to the normal tables. We go directly because guess what? This is already less than, so it's already cumulative. So we didn't have to subtract from 1 or do anything fancy. We just go directly to our normal tables. We look for -1.0 and then 0, 0, because it's -1, that's a Z value, right? So that's a 0, 0. And so our final answer is 0.1587 in terms of how that looks on the normal tables. Now we need the -1, right? So we need to go to -1, and for my tables, this is where I see that -1, and it's 0, 0, and so the value is 0.1587 right here. In part C, we have to find the probability that the return is between 10 and 20%. So now this is between. So let's go through how we do that one. In this case, we again start by writing our probability statement out. So probability that 10% is less than X, less than 20%. This time we have two X values. So we want to go ahead and convert both to Z. So in this case, convert 10%. Convert 20%, we have -1, 1.27, and then we rewrite our statement in terms of Z. And so this is what we have. Then it's crucial to do the sketch to see what's going on in this case. We do the bell curve sketch. We have -1, we have 1.27, 0 is always in the middle. The shaded area is what we want, right? How are we going to find the shaded area, okay? So again, different tables are going to look different in terms of what we have, but for the tables I use, they just have the less than, whether it's negative or positive, it's a less than, right? Some tables have a between as well, so you have to know which one you're using. But this one that I'm using just says less than, okay? So let's go ahead and we're gonna convert this thing to cumulative form because it's not cumulative yet, right? So the way to do that is right here. Okay, so this is how we write it in cumulative form. And it's always the bigger number that's first minus a smaller number. So how do we figure this out? Let's see what's going on here. So remember, everything needs to be cumulative. And when we look at our graph and the normal table, we have everything up to 1.27 and then everything up to -1, right? So we can look these up separately and then subtract the smaller number, this non-shaded area, from the larger number, which is everything less than 1.27, to get the shaded area as the remainder. So one more time, we're going to take the area that's below -1, which is the non-shaded area all the way back to the left. Then we take the area less than 1.27, which is from here all the way back, so including this shaded area and this non-shaded area. And then we subtract the non-shaded area from the total to get the shaded area. And so we're left with this final answer, right? So we looked up 1.27 in our normal table. We did that before. We looked up -1. We also did that before. And we get the remainder, which is 0.7393.